Okay, so good afternoon. So we can start the session. Let me share my screen. So can anybody confirm if my screen is visible?
Yes, sir, it is.
Okay, okay, thank you. So let's start. So this session is about basic overview of generative AI and LLM. So here is the agenda. So basically, we'll cover three sections. One is about generative AI and language model, and then about large language model. So this one will be a brief overview of the concepts, and later on we can go through in detail. So first, starting before starting the session, here I have included some of the terminology. And nowadays, I think you have come across this terminology very often, like pre-training or fine-tuning, instruction tuning, or generative pre-trained transformer GPT or foundation model. So I'll tell you a little bit about this terminology, which we are going to uh, cover in the subsequent slides also. So in pre-training, so in pre-training, what we assume like you have a set of data set is available. Now you are trying to build a model from scratch. So that is called as a pre-training, like where we use some of the foundation model or the basic base models we say. So that is like a building from scratch, we can say the pre-training. And the fine tuning is more, it's like more specialized, where assume you have already a base model is available or a foundation model is available. Now you are trying to do a fine tuning for a specific task. Now it will be general model is there or general language model is there. Now you are taking that language model and you are trying to do fine tuning for a specific task. So this task can be anything. For example, any NLP task like question answering or text summarization, or maybe it can be you can even fine tune based on some instructions. Say so, any kind of fine tuning, or sometimes this fine tuning also possible for some domain specific. For example, like you have taken a general model. Now you are trying to fine tune for a specific domain. Maybe it will be finance or it will be legal. So that is also possible. So it will be like a more a specialized thing where you just take a base model. So base model has the knowledge of everything, but you want to fine tune for a specific task. So so there actually you use this terminology fine tuning. And for fine tuning, what it requires is like first thing is required. It requires a data set. Like on the top of, for example, you want to fine tune on financial domain, then you need dataset for finance, or you want to fine tune for some a question answering. So you need question answers. So that is the fine tuning task. And instruction tuning, like recently we have released our model. We said it is the instruction tuning. Like we have taken a base model, and taking the base model, we have fine tuned with a instruction set. So, for example, in our case, the instruction set is a translated version of ODI, and we have taken those instruction set and fine-tuned a base model. Or our, in case our base model is a Llama model, Llama 7B model. So that will be instruction tuning. And this GPT, when we say that GPT, so the GPT stands for Generative Pre-trained Transformer. So already it is a large language model which is trained in using this transformer architecture. And foundation model already I explained. So where those are like large language model which have trained using a massive amount of data. So this terminology will use in subsequent slide. So Next, we'll start from the generative AI. I think more or less everybody has some idea about generative AI. So when you say generative AI, basically these are deep learning models, so which can generate high quality text or images or any other content based on their trained on. So if you recently heard about this chat GPT, or you have a DALL-E or stable diffusion, so these models are very well generate either qualitative text or images. So these basically already trained on a or a large amount of data, and once these are trained, so they can generate this text or any kind of content. So so why this is more popular so nowadays? Because if you see earlier also language models are there, but the quality of text now it is generating. So it is a it's really amazing. For example, if you see Chat GPT, so you can really like a conversation. For example, if you ask questions, it can give you answer, and again, if you are asking questions based on your previous prompt, it can understand the previous prompt, and again it can generate the text. So or if you are using stable diffusion, you want to uh, generate some images, so the way they understand this context and generate, so that is actually really amazing, and that's why we say, okay, now this generative AI, it's quite popular, and or these models are means really it changes how we are thinking about the capability of AI, you can say. And as I was explaining, so what this generative AI can do, so you can see like it can generate text using like the models like GPT-3 or Lambda, Llama, Bloom, GPT-4, or it can generate code, OpenAI Codex. So if you want to write some code, if you ask in simple natural language, if you want to ask like I want a Python code and this is my requirement, it can able to produce code. Or if you want to generate some images like using DALL-E or Midjourney, Stable Diffusion, it can produce amazing images. Or if you are working in for molecule sequence, so AlphaFold or music or video or multimodal, so any type of content it can able to generate. So those are the like major capability of generative AI. So before going to understand this generative AI, I think the basic thing is about we want to understand about the language model. So that is the foundation. So if you understand how language model works, then I think it will be very easy to understand all the concept. So we'll start with the language model first. So what is a language model? So if you look into the very basic definition about a language model, is a language model, it's a probability distribution over a sequence of words. Assume you have a word, so it can produce the probability of the distribution of word, means for each of the word you can have a probability distribution. Assume you have a sequence of word of length m, then this language model, it can assign probability of w1 to wn to the whole sequence. And this language model, they can they generate probability by training on the text corpora. So what is text corpora? Maybe I can tell you. So you can assume this corpora is nothing but it's a data set. So for example, we say it is a corpus. Corpus is nothing but a data set of text. So corpora is just a plural form of corpus. So assume you have a data set of text on any language. So using this, so you can train a language model, and once the language model is trained, So for now, if you want to assign some probability of any of the sequence, it can for each of the token, it can assign the probability distribution. And why it is important, or why we uh, are means the reason behind the probability distribution, because this probability is intuitively tell us how good a sequence of token is. So that is the key idea. So using this probability, we can perform many tasks. So we know that, okay, whether we want to assign this, for example, in a machine translation, so it will produce some output. So for example, it has, suppose for example, there is two output is there. So based on the probability, you can say that, okay, this sequence one is better, or sequence two is better. So they have many applications. So maybe we'll go through in subsequent slides. This is suppose a simple example I'm providing, where you can see for a sequence. So there will be a vocabulary. So vocabulary, it has, for example, it has a one, two, three, four, five tokens, or sometimes we call it like a word, or you assume a word. So five words are there in this particular vocabulary, and using this five words. So for example, we have a three sequence are there. So first sequence is like, okay, the mouse ate the cheese, or the second is the cheese ate the mouse, or third one is like mouse the cheese ate. So now assume, if you have there is three sequence, and you pass to your language model these three sequence, then it can able to assign you a probability score. For example, first score is say like a 0.02, or second is 0.01, third is 0.001. Then you can come to know that, okay, for which one will be better. So for example, the first one, it seems to be a correct sequence, the mouse ate the cheese, because it has the highest probability. So these language models, so they can capable of providing or assigning this probability to all the sequence, all the tokens of a particular sequence. But how they do it? So for doing that, actually they already trained with a large amount of text. For example, you trained a language model using a vast amount of text. For example, in a wiki, maybe millions of wiki data, you train this language model, and once it is trained, and they know the underlying, like underlying the distribution of each of the tokens. And once it is the language model is trained, then okay, if after that, if you try to do any kind of task, for example, this kind of distribution, then it can easily do it. So so building this language model, actually the main input is the large amount of text. So if you want to build a language model in any of the language, including any of the language where the language model is not exist also, that is you can do it easily. So first thing is like, you need to collect a lot of text, and once you collect the lot of text, you can do it. Also, there are like a different techniques are there, which maybe you can uh, cover in subsequent slide. We can see that, okay, how this model works, or how this model trained. And so now we understand that, okay, what is the language model. So next we'll see like what are the types of language model. So broadly, if you see, there are two types of language model. One is a statistical language model, and the second is a neural language model. So nowadays, mostly this neural language model, they are like more popular, but earlier days, like it was started with the statistical language model. So we'll cover both statistical as well as the neural language model. So first we'll see the statistical language model. So statistical language model is really based on the, or we based on probability, or we call it, it's like probabilistic model. So basically they are capable of predict the next word in a given sequence. So assume you have a sequence. For example, here it is given like the student opened their dash. So okay, what will be the like a next word? Whether it can be book or it can be laptop or it can be exam or it can be mind. So mathematically, if we write, for example, like you want to generate the next token like xt plus one, then it will consider like x1 to xt, and considering x1 to xt, it will predict the next tokens x t plus 1. So I think already you have seen the practical example of language model. For example, when you are typing something in your WhatsApp message, okay, somebody say that, okay, how are you? You say that I am. Suddenly it will find that, okay, next word is already coming as I am fine. So, for example, when you are trying to reply to your mail, automatically it will add you the response. So, all these things actually based on this language model, because already it know that, okay, how to predict the next token. So, based on your context or based on your the tokens already available. And this statistical language model, also there are like varieties of language statistical language models are there, or which in short form we call like SLM. So it can be like a n-gram, unigram, bidirectional, or exponential, or continuous space. So we'll not cover all. So we'll cover the most popular one, which we call like a n-gram language model. So So, so you'll go to, if you say that n-gram language model, actually n-gram language model based on the value of n equal to 1 or 2 or equal to 3. So you'll find either it is unigram or bigram or trigram language models. So what is the unigram language model? So unigram language model, it will be based only on a single word, as it name indicates, unigram. So it consider no context. So, for example, like in the previous example we have seen, when you are trying to predict xt plus 1, so you consider this x1 to xt, and using x1 to xt, you are trying to predict xt plus 1. Oh, So, in this case, okay, so there will be considered no context, and it assumes independent generation words. So here I is equal to 1. So in bigram, it will be like 2 words. So bigram LM conditions on the preceding term. So it will be like for predicting TI, it will have so, uh, for this predicting, assume for this token TI, it will be considered up to TI minus 1. And similarly for n-gram, for example, if it will be n-gram for uh, it will condition on the preceding n minus 1 terms. So for example, here I is equal to n. So for it will, for predicting token ti, it will consider all the n minus 1 terms. So this is like a probability distribution. So based on the probability, you can predict. So this will be like in very basic statistical language model, and it is also quite popular, this n-gram, and still also in many of the NLP application, this n-grams language models are using. And also it can have like a different forms like word n-gram or character n-gram. So that is there. And next is about neural language model. I think neural language models are now more popular, and they are like the capability is more. So their neural models, they use this continuous representation or embedding, word embedding, to make their prediction. So word embedding, if you, okay, I'll give you a little bit background of word embedding. So in word embedding, actually, when you are really input this word, because computers actually, they doesn't understand any word or any language, nothing. They don't understand anything. So they only understand this like mathematical, means the representations. And the one of the representation is like word embeddings, where for each of the word will map into vectors. So like what to vec. So there is a popular uh, popular algorithm, what to break, where, okay, for each of the word, you can convert to a vector, because these vector representations are input for any of our model. So, for neural language model, we need this word embeddings to make their predictions, and they use neural network. I think all of you have some idea about neural networks, how it works, and why it is really important. This neural language model, they overcome the shortcomings of classical n-gram models, and mostly they are used for more complex tasks, like for example, like speech recognition or machine translation. So nowadays mostly you see that, okay, this neural machine translation, although few years back the statistical machine translations were quite popular, but now if you see, everything is coming to neural. And this neural language models, actually, if you now look into, so most of the language models, actually, they follow this neural architectures. So this is like some idea about like statistical and neural language models. And but what are the capability, like what this language models they can do? So actually there are various applications of language models, like content generation. So they can generate content. So for example, if you input a sequence, or input a text, and you want to uh, generate text or next content, so it can able to generate content for you, or part of speech tagging. So this is like a very important applications in NLP. So part of speech means, like, if you have a a sequence or a statement, now you want to find out, like, what will be the noun, or what will be for pronoun, noun, pronoun, verb. So all these things you can use it. So those comes under this part of speech tagging. Question answering. Question answering, okay, like, um, nowadays we are building this kind of chatbot where if you input a questions, okay, it can give you an answer. So question answering, or text summarization, where you input a paragraph or a long text, and it can uh, provide an output of a concise summary. Or sentiment analysis, like you want to find out the sentiment, whether some sentence is positive or negative. So those can do it. Or conversational AI, using speech to text or text to speech, or machine translation. I think this is quite popular. Everybody is using, like, from one language to another. Or code completion. You want to complete some of the code based on the sequence. So all these things can be done using this language model. So nowadays, if you look, most of the things what we are doing, actually, this will be all because of language model, or they are utilizing the capability of language model. So these are some of the applications of language model. Okay, the language model, okay, they can do many things, but what language models cannot do, they have also some restrictions, like common sense knowledge, or understanding some abstract concept, so, or making inference based on incomplete information. So these are like some of the restrictions or areas where language model also fails, or they cannot do. You need to keep in mind. So language model is great. Now we understood about the language model, or some overview idea of language model. Now, uh, what is LLM? So now we'll discuss something about large language model. So large language model, if you see, actually these are language models, but in a the scale will be little bit high, or we can say that, okay, this will be also this language model, or a language model which consists a neural network with many parameters. When say that scale is high, so it consists of typically billions of weights or more, and it trained on very large quantities of unlabeled text. So unlabeled text means, now assume you have text, So those have not been assigned, means not been labeled or assigned with any of the tags. So these are simple raw text. So if you take a raw text and using that, okay, you can build a language model. So mostly this language model, they follow the transformer architecture, which I have highlighted in the right hand side. So this will be the architecture. So if you want to understand the complete architecture, so there is a paper is available. You can go through the S paper, or we are also planning for some um, uh, for a special session like where we can explain about this architecture. So so mostly, if you look into large language models, so they follow this architecture. So that is quite important to understand this architecture. So if you want to really want to work in large language model, so I think it is suggested to understand this transformer architecture. So nowadays, if you look like every week or like every uh, any day, if you say there will be some development and new language models keep on coming. So here actually I have taken from this survey paper or survey of large language model. So this paper you can also go through it. So this paper is quite uh, 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 quite in detail. They explained about this LLMs, like all the available LLMs. So if you see these LLMs, like starting from 2019, when from like Google T5, 2019, 2020, like GPT-3, 2021. So you can see like how fast this uh, growth is coming, and new language models are keep on coming. And also like here we have considered only the size of language model. They have more than 10 billion. And so now actually we are in 2023. So you can see like this llama, bird, so vicuna, so or pythia. So all these are like a in the recent or popular large language model. But apart from that, also you can see like a lot of language models are there. Like some are like open source language models, some are commercial language model. So and their size and capabilities are keep on increasing. So I suggest you can go through this paper to understand the large language model in detail. So this will be a nice survey paper. So next I'll come to a little bit about this LLM types to understand like among all these language models, like how actually we are classifying it. So mainly if you look into, so these language models, if you'll see like GPT, T5, BART, so many language model or large language models you'll find. So mostly if you'll see like we are categorizing into three types, like autoregressive or encoder decoder or masked LM. So autoregressive, like if you look into this language language models, so this GPT actually these are falls under this decoder. Maybe I'll go through a little bit this architecture. So if you look into this transformer architecture, actually there will be two part. Like if you look into, there will be a encoder and there will be a decoder. So where encoder mostly they try to encode from the input text, and decoder will produce the result or the generate the output. So if you look into these autoregressive models, actually they are like use only the decoder, so which are like the GPT, and these T5s are like based on this encoder decoder, and this masked LM, uh, or we call it BOT, which is one of the uh, popular language models. So they are like a masked LM. So maybe we'll discuss in subsequent slide like how these models work, because that is also quite important to understand, like what is their difference and how this masked LM works or this autoregressive model works. So that we'll discuss. So if you look into, so maybe it will be very easy to know that okay, this GPT is actually which models are falls under which type of category. For example, like as I mentioned, this GPT falls under decoder, or T5 under encoder decoder, and bot is under encoder or masked LM. So this will be the high level LLM types. So already, as I said, like this autoregressive language model, or GPT, so they uh, fold under this autoregressive language model. So, but what is autoregressive language model? So, autoregressive language model, actually, these are model, uh, or which is, we call it like a feed forward model. So that predict the future word from a set of word in the given context. Now, if you provide a input context, like a, if somebody have already started using this chat GPT, you know that okay, you want to provide some of your instruction and an input. uh, then okay, chat GPT will start producing the output. So based on your input context, it can produce the feature words. So, and this chat GPT, it is a fine-tuned version of GPT-3, or we'll call like the 3.5 Da Vinci. That is the model. And fine-tuned, what is fine-tuned? Already, I think in the beginning I have explaining, like in fine-tuning now, assume you have taken a base model, and using the base model, you have tune it for a particular instruction set. So for example, like for the chat GPT, now you have taken instructions and you fine-tune so that it can uh, behave like a chatbot, so which you can interact with a chat GPT. So, so that will be like a about auto-regressive language model. So next we'll see about when we say that okay, masked LM or bot. So bot actually, before explaining bot, okay, I'll give little bit a background of the bot. Actually, it is not very new, but actually it has an open source LME, NLP pretend model. It was actually developed in 2018. It's a little bit, or we can say like it will be like a little bit old. But if you're like the first model, which is I think most one of the most popular language model, and so the bot trains a language model, so which takes both the previous and next token into account when it will try to predict it. And it also based on this transformer architecture. And also, you want to know like this bot actually it uses word pieces. But what is word pieces? For example, I have given a simple example. For example, like you say playing. So playing means okay, we can divide it into word pieces. It will be play plus ing. So excuse me, yeah. So this will be like a word pieces. So instead of word, the bot actually uses these word pieces, and it will be pre-trained on a large corpus of unlabeled text, which includes the entire Wikipedia, so around 2,500 million of words, and also a book corpus, which is around 800 million words. So you can imagine like how what is the size, and what will be the size of input on which these models have been trained. That's why they are like perform also quite well. And it also actually, but actually they follow this attention mechanism. So attention mechanism, okay, briefly I'll explain what is attention. So in bot, actually this attention mechanism, uh, it allow you to let each token from the input sequence to focus on any other token. For example, if you see like these two words are there, like the CLS is for like uh, assume this will be the beginning, and this will be like some separation. Like the animal didn't cross the street because it was too wide, so it was waited. So if you look into each of the tokens, for example, here it has trying to focus on each of the tokens from the same sentence. But if you look into the word it attends to every other tokens and seems to focus on street and animals. So if you observe this actually these lines are, some of the lines are like very thin, and some of the lines are thick. So if you look into this particular word, it has actually focus more focus on two tokens. One is and street, and second one is animal. So which we call like the attention. That means okay. So whenever it will try to produce the output, so it will try to focus like which word means. For example, from the context word, like which one it has to focus more. I'll give you a simple example. For example, assume you want to do a machine translation. So in machine translation, like how a translator do. So translator read a, for example, read uh, one word. For example, you want to translate from English to Odia. Now you read one sentence of English and you try to translate it. But during translation into Odia, so again you will look back to the English sentence, and on few of the word you will have some kind of attention, so that okay, you can look back and you can put more attention for some of the words and you go on translating. So this is like this is like a typical example of attention. So but already taken care that about this which is called attention, or sometimes also we call like a self attention. And for this attention, actually uh, there will be a separate mechanism is there. So bot uses actually 12 separate attention mechanism for each of the layer. So that's why actually it will be um, the output will be quite good also. So if you look like in transformer architecture, people it started with like NLP, like machine translation, and slowly it has gained popularity, and it has gone through all different kind of domain, including speech or image processing. So the main what I can call the main one of the key concept behind this transformer architecture about this attention. And how this bot exactly work, as we said, it is a masked language model. So we'll talk about masking. So for masking, it uses like a this bot uses two strategies. One is like this mask language model, and second one is a next sentence prediction. So I'll talk about mask language model. What is mask language model? So this bot randomly mask words in sentences and predict them. So mask means what? For example, like this will be an input sequence. Uh, uh, it will some of the input sequence, assume 15% of the word in each sequence will be replaced by a special token, and this special token is called mask. For example, this will be a mask, like the whole sequence will be, or the input sequence is the computer is not working, it's unable to start. Now, from this sentence, I'll randomly mask two of the tokens. For example, first token I have masked is like a computer, and second token I have masked is start. Now, masking these tokens, I'll try to reproduce it. So over the period of training, so I'll try to reproduce it. So maybe in the first iterations it won't able to produce, but I try to train the model so that it can able to reproduce it. The model then attempt to predict the original value of the mask word based on the context provided by other or non-masked word in the sequence. So this is the my training. So over my training, I'll try to reproduce this or try to find out what will be the original word. So that will be the first idea of or the first strategy which we called mask language model. And second one is we call this a next sentence prediction. So next sentence prediction is quite easy. So here actually you assume you have two sentences and you need to predict. So, second. So in the training, assume you have a two sentence, like a sentence A and B, and you have a for example, your sentence A is this computer is not working, and sentence B is it's unable to start. So you need to find out, like for example, the label is next sentence, whether the sentence B it's a follow sentence A or not. So that you need to decide. For example, the computer is not working and second sentence B is coffee is very tasty. So label, not next sentence. So if I ask that, okay, is this sentence will be follow this sentence A? The computer is not working, coffee is very tasty. So there will be no relation at all. So okay, this is not a next sentence. But in the first case, okay, the computer is not working and it's unable to start. Yeah, it's very well understood that okay, the second sentence or sentence B follow uh, the sentence A. So that will be the idea, the next sentence prediction. So in the training process, the model receives pair of sentence as input and learn to predict if the second sentence in the pair is the subsequent sentence in the original document. So using these two strategy, but try to build the model so that it can able to predict the next sentence, next tokens or next words. So if you look into the applications, I think already you are using, like for example, when you are searching some of the in Google, for example, if you type SANF, then it can automatically it can suggest you like San Francisco weather or San Francisco, or for example, you are trying to reply to a mail. Okay, somebody say that okay, here you can see that does next, if you type T, it will automatically fill up Tuesday work for you. Or for example, like you are in your WhatsApp or some where you are trying to type something, it can automatically it will suggest you okay what are the next word. So these are like based on this bot application. So hope I have given some idea about this language model. So this presentation, we cover actually the overview of generative AI and language model and LLM. So here I'll stop recording. Then maybe you can go through some of the queries and answers.